Okay, so today's Monday. On Wednesday, I'll have Kyle Keithis, my colleague, come and he'll talk about laser cutting with you guys, where you can find the templates, how you can send them for time, etc. At that point, I think what I'll do is I'll officially sort of assign you guys that prototype number one, and you'll have a week or two to sort of go through the motions. But essentially, you'll find yourself maybe it's a difficult or first time situation for you, but it shouldn't be here on after, which is I know before I'm done that I'm going to need to laser cut stuff. And so I'm going to set up my appointment time so I make sure I get into the queue for laser cutting before all the slots are gone. And now I have a deadline to work towards to finish preparing everything for laser cutting, right? This is something you have to confront as well towards the end of the semesters, midterms, and things like that, when everybody needs to make models for studio all at once. And so laser cutting and 3D printing, those sorts of things, become something that you have to sort of think about in advance, think a few steps ahead. Go ahead and sign up for your time, make the appointments, but then now you have a concrete individual deadline for getting things prepared so that you can go right in, get things laser cut, and then you have a few days to sort of put it all together and glue it and things like that, okay? And again, as a reminder, I do this every year, and you can see going back several years, in fact, right? I collect all of these when you get the finals. I look at them very carefully, I photograph them meticulously, document them, then I give them back to you within a reasonable week or so. Okay? I see them sometimes populating in studios, or somebody beams into class on Zoom or something, and I usually see them in the background and sort of pinned up on a bedroom wall or home office wall or something. But again, right? You can see that there's a strange array of these things. And I just point out that sometimes, for whatever reason, some students will pick to sort of change the material entirely, or just the color of the material between the sort of shape components of the grid system. So if some of you are thinking, and I'm going to say this more than once over the next couple of weeks, but if some of you are thinking, I have a really complex component, has a lot of folds in it, right? The thicker the material is, the harder it is to make all those folds. You can go as thin as cardstock. In fact, I've used tissue paper, because the hardest part was just taking it down so it wouldn't move in the bed. You can go with something thin, like let's say cardstock. It's really thin. If you need to go thinner for your shading components in order to make a set of scoring with the laser cutter, you don't cut all the way through. You just cut part of the way through to make a score, just again to show you where all those folds are. So you have some options at your disposal here to play around with here. Yeah. So for example, I think this one had a lot of folds in it, and so I think he went. If I can just zoom in here, he went thinner with the sort of shading components. Just zooming into that, this isn't my favorite one or anything, but just zooming into this, I think you can see several things that are helpful. One is that, again, all of those edges that are touch, right? Those don't all have to be separate triangles that you have to glue together. But if you can cut the overall shape and then use a laser cutter to just score those fold lines, right? The break lines. Then it again gives you a natural way to sort of makes it easier to fold it. It also shows you exactly where you're folding it, right? And then you also see here that each one of these has a very specific place, and he's labeled them as such so that he knows that 24 goes here, 33 goes here, 43 goes there. Right? So we'll talk about that today, and I'll show you how you can generate those labels. Because what you don't want at the end is a really complex jigsaw puzzle. You want everything to be labeled so that you know exactly which component goes into which cell, which notch attaches to the other notch, etc. Okay? So I'm going to talk about a lot of things today. I'm going to go through a workflow that's comprehensively gives you all the way to the end going from where you are right now to having all the files ready to laser cut, okay? And I'm going to record it so that you guys can always refer back to it. We'll do this over and over again, trust me. But I do want to get through it one whole sweep today and get it recorded for you guys so that the recording for the entire demonstration is available to you from here on out, okay? So if you have some questions throughout the process, jot them down. Don't worry about interrupting. Wait till the end, and I'm happy to answer any questions you have, okay? But I do want to get through this without too many interruptions. Again, just so that for posterity's sake, right, you have this recording. It's useful to you over the next few weeks. But anyway, I photographed these, and you can see that some of them range from really interesting to really boring, and I won't tell you which ones I think are interesting or boring, but let me see if I can find anything else here that might be helpful to sort of point out in advance. All right, let's see. No, maybe not. All right. So the next thing I'm going to do is point you to today's Canvas post and the modules. I've labeled this literally putting everything together, everything you've done so far, and getting it ready for laser cutting. Right? You can see that there's several steps performed. I've tried to break it down into discrete steps with a logical order so that you can, I think, hopefully internalize it a little better and understanding it and then putting it to use. Okay? But essentially, what we're going to do is define the actual grid shell geometry that you will then populate with the shading components you've been working on. Okay. And not only will we then populate that with your shading components, but we'll also populate it with a two-way rib structural system that already has the notches built into it. Okay. Then we'll lay all of these things out on the XY plane in top view, flat. So we're taking three-dimensional components that are modeled in place and laying them all out, labeling them all in an orderly way so that you can then start to situate them within 18 by 32 rectangles corresponding to the size of the laser cutter bed and the size of materials you're going to use in the laser cutter bed. Okay? So this is not uncommon to sort of say, well, I have a bunch of three-dimensional things I've been modeling. Now I need to scale them down to, let's say, an 8th scale model or a 16th scale model. Now let's lay them all out flat so that I can laser cut them, or there are other CNC technologies besides just laser cutting, right? I could, if I'm scaling up bigger or thinking about like wood instead of chipboards or acrylic, then I could take it to the CNC router, right? Which takes a milling spindle and basically does the same thing, cuts out shapes, right? Or if I wanted to scale up even bigger, we have a plasma cutter that's CNC, so we could cut through steel and other ferrous and non-ferrous metals with it, right? And so you can see that these applications can begin to scale up quickly if you were going to prototype this, let's say at full scale, rather than just the sort of scale that we're working at. All right, so we'll define this grid shell geometry. We'll use the grid shell surface geometry to then generate the structural ribs, the two-way structural rib system. Then we'll also use that same shell geometry, and you'll populate it with your shading components. So you'll have the grid, the structural grid, and then you'll have in between each of those ribs, you have a cell. Then you'll be able to sort of generate your shading system to sit one each in each of those cells, right? And then to sort of modify that component graph so that you unroll everything out flat, and then add labels and begin to order things to make sure that you know which piece goes where. Okay. Now, the second theme for the day is that we're going to be doing things that Rhino doesn't just do natively. So, in other words, I could manually begin to sort of find all the isoforms in the surface, generate a set of ribs in both directions, offset them, start to make surfaces, and then roll them manually. What we're going to do is we're going to show you several different ways that you can extend your software tools, get under the hood, if you will, and make them do things either more efficiently or do things that they don't have necessarily native buttons to do. Right? So I'll show you an end user script, Rhino scripts, right? It can be written in either Visual Basic or Python or C# when you're working in Rhino. I'll show you a script and you're going to use that script to generate things yourself, and you'll see how to use it. It just occurred to me that I forgot to upload that file, so I'll do that at the end as well, so you have that Rhino script. We'll also be loading in a plugin that extends Grasshopper to give it some of that unrolling capabilities that Rhino has, but that Grasshopper doesn't necessarily have natively. So we have to install a free plugin, third-party plugin through Rhino's package manager. Okay? So we'll talk about a lot of these things, but again, thinking about, hey, you know, just like if I'm using a pencil, the pencil's good at certain things, but I don't just accept what the pencil gives me if I'm trying for a certain idea. It should be the same way with critical use of any digital media, right? Rhino will give you shapes, but you know, make it work for you, right? There's ways of doing that to extend it beyond what it can just do out of the box, what the software developer lets you do. Okay. And in fact, at lots of bigger firms and then also some boutique design firms, there are whole units in the firm just devising sort of computational scripting and Grasshopper graphs, or going in and starting to create those custom families in Revit, so that the design team can begin to do these, sort of deploy the tools based off of specific problems that they're working through, right? If you don't believe me, right, I was just on LinkedIn and Populous. You guys know the firm Populous? They do most of the stadiums these days, including the Raider Stadium and the Sphere. So they do a lot of sports and entertainment venues. This has popped up. This looks really familiar, doesn't it? Right? Like, I mean, Jesus, that's like a pyramid, right? But then, so here's an apex point, right? These are four-sided things. And I tell you what, like the companies or the countries that are actually investing in infrastructure, in making things and sort of building the future, they love this kind of stuff, right? So if you have any aspirations for working in a firm that works internationally, right? That might be doing projects in Dubai or somewhere else in the UAE, Saudi Arabia, Northern Africa, parts of Europe, Eastern Asia. India is growing very quickly and ramping things up. China, of course, create whole cities from scratch. Again, if you want to work at a firm in LA or New York or someplace like that, then these tools can come very handy. Sort of, in fact, are expected that you know how to use them. All right. Putting everything together. Step 1, define the grid shell geometry. All right, I'm just going to read this at you for a moment. Using the given GH file, which you'll find right here, you can download it. You'll move some sliders around until you find an exact surface patch that you would like to use. This will be your grid shell shape. A lot of you ask me like, well, I couldn't get this curve that I'm lofting between 3 curves, the surface, or if I use a planar one. Doesn't matter, right? You can use any surface you want, but now I'm telling you for the prototyping and for this project, now you're going to define a surface that's going to be your grid shell surface. That'll be populated 10 by 10 with your so now I'm specifying what that surface is. You have a tool that'll subdivide any surface. So which one do we use? We'll pick it from here. What you'll notice is that you move the sliders around and you'll see the area sort of move around this larger surface. It's sized very specifically to give you a surface patch so that when you start to break it up into structure and skin, all the pieces will fit in that 8 by 32 envelope, laser cut that. So that's why I'm doing that. I've scaffolded that part for you so you don't have to worry about creating some sort of weird shape. But you can do it with this tool that I give you, this Grasshopper graph that I give you, and it still fulfills and works within the parameters that you're expected to work within for production. That's a really important production constraint, right? Look, when I'm designing something, let's say a piece of precast with, and let's say I have a bunch of custom precast panels, and I've done this before. you look at how to divvy that up into pieces, and you say, A, it's gonna have to sit in the back of the truck, which means it has to fit within highway standard truck bed size. And two, if I have a little offcut or piece that isn't supported, it might snap off in the truck, right? So thinking about these sort of logistics ahead of time saves you a lot of headaches later, and ultimately, hopefully it will keep you in budget. Right? So when we think about the tool that we're using, we're gonna use a laser cutter that has a certain bed size. It has, a big container so that it can zap things with laser beams safely, right? You can be outside of it. But within that, there's a limit to the size, right? 18 by 32. So if you think about this as a printer, instead of spraying ink, it just sort of zaps things with a laser on a gantry moving around. You can only do that with an 18 by 32 model, right? So, if you get too close to an edge, right, and I'll show you this, you'll get something that's too small, and then you'll have something that's way out of proportion. Don't do that. Strive to pick a patch that isn't symmetrical. I want to emphasize this, right? If you have, in particular, some people pick bilateral symmetry. So what happens is, if I look at this and I go, this rib and this rib are pretty much the same, and this rib and this rib are pretty much the same, which one goes where? It gets that much harder to figure out which cell is which. Okay? So I'm saying, try to strive to break symmetry when you're selecting these things. And I'll talk about this very specifically and show you what I mean here in just a minute. Then last, finally, you want to make sure your Rhino is set to inches. You always want to double check your units when you're starting a new CAD file for any platform. AutoCAD, Rhino, Revit, all that stuff. And make sure that the units are set to what you need. That has profound implications of the scale that you want. So that way, if by default, Rhino gives you a file with millimeters, to let know I have a small object that needs to be in inches. And that way, when you then bake something in from Grasshopper to Rhino, it's, it will fit 18 by 32 inches, not 18 by 32 millimeters, which is like this big. Right? Millimeters are quite small. They're cinnamon and a centimeter. Right? So, yeah. All right. So, let's look at this file that I'm giving you for step one. There we go. You can try to follow along if you want, but don't let that get in the way of you just paying attention, right? I've laid this out and I'm recording this, so that you can go back and do it step by step in your own time at your own pace if you need to, okay? Some of you have already downloaded the file and are already going to town, and that's fine too if you're a fast, quick worker. All right, here's where, instead of looking at recent files, I might say new and say small objects in inches. And again, just load up the template that uses inches already. Okay. Now, really important. If you forget that step and you have Rhino open, you're like, oh, how do I set the units? Okay. Here's where. You go to Tools, Pull Down, Menu, and Options. I'm holding my cursor there. You're in Windows, Tools, Pull Down, Options. This box that pops up has all of the settings you need in Rhino. It's a little different if you're running the Mac OS version. It's up here. You go to where it says Rhino, and then you can find settings, and you can find units in there. Okay, but in Windows, it's Tools, Pull Down, Options, and when I open that up, it gives me a box with a lot of different options. There's a menu on the left, and part of the menu down here, right here, is Units. When I select Units, it'll tell me which units I'm already working within, and then you see that pull down. If I wanted to change it, I could use this pull down and select the units that I want. So if this was millimeters, then I could change it here to inches and hit OK. Okay, and it'll be in inches. Again, just want to re-emphasize that, right? Like you should always do that anytime you're using CAD software. Whatever, pick your poison, right? I don't care if it's Rhino or SketchUp, AutoCAD, any of those, right? Revit, of course. And so, okay. We've set the units. I'm going to go ahead and open up that Grasshopper file that I give you. It is called, let's see, Surface Shell Surface Classifications Revised for 2025. Okay. And I showed this to you the other day. I gave you a sneak peek on Wednesday when I was just quickly showing you some things. It's essentially a sine wave swept along with a sine wave, right? And all I'm really doing is creating a few functions, like cosine of x times sine of y for z, and I plug in a set of x values and step up, and a set of y values and step up, generate the z values, then plug them all in x, y, and z's for a grid of points, and then I surface that bad boy. Nothing you really have to worry about. Suffice to say, though, if you remember any of this stuff from Algebra 2, trigonometry, and calculus, maybe even a little physics, then you could, be your own Antonio Gaudí. Instead of using Hein-Ching models, you can make digital Hein-Ching models. Right? A parabola is just y equals x squared, right? Quite easy to do, actually. All right. Now, what you'll see here is that down here I can change these sliders. And I've highlighted this subsurface, right? So I have this larger surface, and now you can use these sliders to identify which part, which patch, which subsurface, which plot of land that you want here, right? So here's what I mean, right? As I move this, you can see that the size still stays the same, right? In other words, this thing isn't going to get a lot bigger or a lot smaller. Everybody's going to have approximately the same scale, right? And that scale, at that scale, when you break this down into pieces, all of the ribs and everything else will still fit on your 18 by 32 max size laser cutting envelope, okay? So that's why I've done this. 2, if I get really close to the edge, let me just select this again, then you can see that it's just going to slide right off, and I'm going to get something that's not good, right? So make sure that you maintain that margin just so that you make sure that you're getting the full surface patch that you need, okay? And then 3, I'm going to try to position this so that I don't have symmetry. So when I look at the isoparms this direction, I have a high point that goes to a low point, and there's an inflection here. And it's the same thing here in this direction, right? So now I know exactly what end is this way and what end is this way, because there's a high and a low, right? And a high and a low. So this isn't bilateral symmetry. Now conversely, if I did this, oh shoot, right? You see this edge where my cursor is running along, and then this edge where my cursor is running along will be pretty much the same, right? I have almost bilateral symmetry. It looks like a nice sort of dome-like shell, but in reality, it's going to make it that much harder for you to sort of understand the logic when you're working out in parts up here in physical space, tangible space. So I'm going to go ahead and shift mine over so it's not symmetrical in either direction. Okay? Make it easy for myself. And once I have that, I'm almost done with this grasshopper file. I just need to take this little subsurface that I want to use for my grid shell and bake it into Rhino. I'll just bake it into layer 1, hit OK. I can close this grasshopper file forever because this is the shape of my grid shell. Everything that I do, shading components, structure, everything's going to be populated on this. Nothing else. All right. Now, there's a couple of things here. One is that just because I'm thinking about this, I baked it into layer 1. It's baked now. Anyway. So I'll say shell geometry. I'm just going to rename that file or that layer shell geometry and start to utilize my layers and try to manage those. So as I start to add more and more things, I can keep them on different layers, right? And I can always come back and look at this master geometry that I have, right? This is the shape. Everything needs to sit on this shape. Okay. I'm going to go ahead and move this out of the positive x, positive y quadrant. And you'll see why in just a little bit, but as we start to generate things, the script will start to place the items it makes out in the positive x, positive y. Then when I unroll things with Grasshopper, they'll place things in the positive x, positive y. So I just want to make sure that I'm not overlapping a lot of stuff. I'm just going to pull this off to the side. So it's not in the positive x, positive y quadrants. Because everything that I generate from here on out is going to sit there automatically, and then I'll have to sort of move things away, make things on the right layers, etc. All right, so you guys ready to see the next step? Which is using this grid shell shaped surface to generate the grid shell structure, right? Using the given Rhino scripts. Sorry, I forgot to upload it. I'll upload it right at the end of class, sorry. Shout out to my pal Andrew, who wrote this back in the early aughts when he was doing his master's at the Architectural Association. You'll generate a two-way rib structure, basically the grid shell structure. Right? And so we'll ask you for some very specific parameters. You guys want to see how to do this? This is great, because this is like, if you figure out how to like write script, right? First of all, we're figuring out how to do that in Grasshopper without actually write the script. But you can see that if you are quite adept at Python or C# or something, you can actually write your own stuff and then automate things, right? So this is where you go, oh, I'd love to play around with this, but I'd rather just sip my coffee and watch my computer do it for me, right? And you'll watch and you'll see what that means. So in order to run a Rhino script in the Windows side, again, I go to Tools, Pull Down, and I go to the Rhino script, and I go to Edit. That'll bring up a plugin. It's called Rhino Script Editor. Right, so Tools, Pull Down, Rhino script, and then that Edit. And it might take a minute. There it goes. There's my Rhino script editor. Right. And now I have a file. It's already loaded called surface to grid shell 01.rvb. I'm going to share that with you as soon as I can, right? But just watch what this does, right? So, sorry, I'm just trying to resize this window. There we go, so we can see it a little better. Right? Let's take a quick look at what's actually happening under the hood here, right? So, if you really wanted to write code yourself and get under the hood, you can do that. I liken this to sort of when I take my car, right? I know how to change my oil, but my driveway isn't flat, and so most of the time I just take it into the dealership, keep the warranty under, going, and because it's like a 100,000-mile warranty for so let them do it. Like it's like $50, and it's less money I have to pay for my backaches later on, trying to go underneath my car trying to change my own oil. You can do this, right? Or you can just again use this stuff that you can find, or use these tools over here, right? Sort of liking those two things. But honestly, your software is a bunch of code, right? It's a bunch of functions, and every time I hit a button over here, it calls up a function that looks similar like this, right? Just we don't see it, right? But you can expose that stuff and take a look at it, and even write your own, right? So there's no button over here on the left-hand side that takes a surface and breaks it up into a set of ribs in two different directions, using V's, that's using number of divisions at once, just like we do in Grasshopper, right? And then starts to generate all these things for you, right? So we can write a script that does that. You can see that up at the top, where you have that sort of apostrophe at the very beginning, it's sort of greened out. Those are just comments. Those are just things that the computer doesn't read, but anybody looking at the script can read. So might have to deal with authorship, copyright, date, version, or sometimes, sort of giving it labels and things like that along the way, right? Commenting throughout, sort of, so people can read it sort of in natural language, what each part does. And then look, where we're used to having number sliders, right, or plugging in a number, we have a set of variables that are named, and then just basically just giving it a list, saying, okay, we're going to have some variables here. These are what they call. We're going to have something called strings, and let's see, what's the other? Strings would be like text, and then we'll have some real numbers and things like that. But essentially, we're going to have something called source surface, and a UDiv and a VDiv. Sounds kind of familiar, right? Divisions in U, divisions in V, right? Height, X grid, Y grid, thickness, and we're just giving those labels. And then later on, we're saying, let's find what this UDiv is. We'll give the user a message in the command line that says, enter the number of tiles in the U direction, and let them enter something in and hit enter. And then we'll, whatever number they type type it, we'll call that udiv, and then we'll use it later on down in the recipe. Right? So that's kind of how this works. Right? You can see that there's several different lines, and sometimes when you have certain tools that you make, right, that you're going to use over and over again, you can just use them as functions down at the bottom, right? And you can just refer to the function at the top. Maybe saves you some lines of code later if you're using those multiple times. But anyway, I just load this in. I can just say File, Open, and open that RVB file. And this is what it looks like, right? You see it line by line. And when I'm ready to run it, I just hit this green play button, Run Script. And the script editor disappears, revealing Rhino and asking you, it's running the script, right? So it's saying, no, select a surface to populate the tiles, right? So instead of making a surface widget in Grasshopper and then plugging that in to how many times we want to divide it with the set of parameters, it's going to ask us these things right up front. So I'll say, okay, let's populate this surface. Now enter the number of tiles in the U direction. I think I've been using 10 and 10, right? So I'm just going to type in 10, and then for the V direction also 10. Now enter the height or the depth of each strip, right? This is the sort of structural depth. And I'll go ahead and just say like 0.75, I'll say 3/4 of an inch, right? Because we're using inches as our units. If we say 0.75, that'll be 3/4 of an inch. Enter the X distance between unrolled strips. So what it's going to do, it's going to populate this with a set of ribs in the U direction and the V direction. It'll also take each of those and lay them out flat on the XY plane. And when it's laying these things out, it wants to know how much space they want between the first U rib and the second U rib and the third U rib. And it also wants to understand, once it runs through the U's, the spacing up this direction to start the V's. Right? So I'm just going to give it something that's probably too big, but I just want to make sure that none of these things are overlapping, and then it becomes a big pain in the rear. So I'm going to say 20, and I'll say 40. Why not? Now the material thickness, that's critical, right? Because it's going to generate notches, right? And those notches are where this rib joins into this rib. So that material thickness is critical. I'm just going to go with the standard 0.020, but that's something that you either want to be very mindful of when you're buying the material and look at it. If you have any questions about how thick something is, you can take it to Kyle and the folks in the laser cutter room and ask if they have digital calipers. You can mic it with a micrometer and find out a fairly accurate thickness, right? So I'll say 0.020, and now I just watch it do my work for me. When it's done, the editor box comes up, but what you can see, I think, is that it's populated this with a two-way rib system. Now let's also notice that when I select each rib, and I go to the properties, it's labeled, right? So that's V rib number 8. So that must be, that's V rib number 9, that's V rib number 10, 7, 6, 5, 4, 3, 2, 1, 0, right? Makes sense, right? For 10 cells, we're gonna have 11 ribs. And they start counting at 0, so V0 all the way to V10. Yeah. And if I do the same thing in the other direction, you know, that's U3. All right, so that's U0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's labeling these things for us, and when I go to the top view, you can see that it put it in this top quadrant that I just moved my surface away from. This is why I moved that surface away. So I wouldn't have this thing just sort of sitting out here, ribs. Let's just zoom in on these, but you can see that it's unrolled each of these ribs and laid them out flat. I'm just going to turn off, oops, sorry, I didn't mean to do that. I'm just going to go to Tools and turn off this grid so you can see maybe a little better on the projection here. There we are. Okay, so you can see that we have a set of black lines or curves. That's the sort of through cut, the overall outline. For the notches, it just made a little box, right? It didn't actually like trim everything out because, you know, at that point it's kind of like, why bother, right? Then it also gives you these score lines. So if this thing is really bendy, and has to sort of bend into place as you're starting to fit all these things together, that if you have a thicker material, that can actually help with it sort of, again, being a little more pliable without snapping or ripping. Right? And then we have a label. Now these labels, some of them are curves and some of them are text objects. I'm going to advise you A, the font that's being used, and A, the size and the placement of these, and just simply add your own labels. So here's why, right? If I think about, let's say we have this 0, right? And I'm just going to score this. The laser cutter has to go around once and then a second time, right? For a V, it has to go this way and then this way again. Right? We have a lot of redundant lines. And if 1 or 2 don't really matter so much. It goes by quick. But when you do that, multiply that over all of the labels you're going to have, right? You double the amount of time it's going to take, which is double the amount of money you have to pay, right? For time. So what I'm saying is that there are single stroke fonts. A V is just simple 2 lines. A 0 is just one sort of arc or whatever. So that you can begin to really optimize these things. So let me just point this out. But if I wanted to relabel these, for instance, let me just zoom way in. I'm going to go to the text tool. Where is that at here? Let's see. Why is my OSNAP over here? They're always moving things. Why? It's not an improvement. Where's text? Usually has like a T. Am I just stupid? Where is it? Maybe I just type in text. Oh, here we go. I'll just type in text as the command line. Here I can give it a very specific way to format it if I have decimal places, which I don't. I can give it a height or scale. I can tell it the exact font that I want. And here's the font that I would recommend using. I believe it's called Rhino Single Stroke Architect or something. Let's see. Let's go down here. Rhino. Where is it? Oh. If I can't find it today, I know Kyle will be able to point it out to you guys on Wednesday. And I'll post it on the official name of it again. Let me just, there's so many fonts. And they're all most of them are pretty pedestrian and terrible. It's like, could we just maybe pare this down to like the useful ones here? Let's see, self, maybe it starts with an S. Self, or single font, single stroke. Let's see here. Here we go. Single, here we go. It's called SLF Rhino Architect, RHN. So single line font, Rhino Architect. I don't know why they hide it like that. Okay. So if I simply say the height is going to be 1/8 of an inch, let's try that, why not? What text do I want to do? V0. Okay, maybe that's too big. The height is, I don't know why it's saying, 16th maybe? I don't know why this is 625. 0.0625, let's do that. Model space scale, I don't know why this is set to 10, maybe that's why. Okay, there we go. Now it's at 16th, right? I can simply place that very carefully and get rid of this other garbage, which wasn't joined even. You know, the script, it still works, but it's a little buggy now after moving on from Rhino 3 to Rhino 4, 5, 6, 7, now 8, and soon 9. So, but now I can make my own. I can move it into a non-conspicuous place. What I recommend doing, you're going to see some of these marks. I mean, you saw those on some of the examples I just showed in the photos of. Just make them perfectly imperfect then, right? Like put them in the exact same spot for each rib so that it sort of serially reads as, you know, these marks are there for a reason. They're not haphazardly placed. They're not accidental, right? So in this case, I might just sort of, again, try to place it as close to the corner as I can and then move on to the next one, okay? But that's one thing I'm going to advise you to do, right? It might take you an extra 5 minutes in Rhino, but it might save you an extra $8 in an extra hour of laser cutting, right? So when I look at the trade-offs, I'm not saying, like, the trade-offs for these notches and trying to trim those out, not worth it. The trade-off for redoing those labels, worth it, right? Especially since how big those things were, they sort of fell off the page, and they look goofy anyway, right? So be particular about these things, and again, weigh the trade-offs each time. I think you'll start to see that, you know, really every decision, there's pros and cons, but when you start to understand what you're really trying to accomplish, where you're willing to compromise, where you're not, I think is the key thing, right? And I think that's a key part of design anyway. So this one would be V1. I'll just go to text, and I'll change this to V1, leave the same parameters, place it there, call it a day, right? Move on to the next one, V2, yeah.
You have to move the text to a certain layer?
Yeah, that's a good question. Right now, they're on the green layer, which is, for this point, at this point is the scoring layer, right? So you can see that when it did this, it put the V strips on a layer, the U strips on a layer, and then all the sort of stuff to cut. The notches are on this red layer, and then all the scoring is on this green layer. So that's why I'm just sort of keeping it real by keeping it on the green layer with its properties. You see how the green layer is check marked? It's a very good point, right? Again, as I do this stuff, rearranging things, moving things, ordering things, adding things, subtracting things, I want to make sure I'm doing them on the right layers. So very good point. Thanks for bringing that up. I'm not going to bore you guys to death by doing this 20 times, but you get the idea. Within 5 minutes, I could get this thing done. And, the other thing to keep in mind, right, is that if I wanted to make this much more efficient, I type in move, and I could start to move. Let me turn off the ortho. And I could start to nest these things much closer to each other. As long as they don't overlap, right, I can begin to better utilize my materials and try to minimize the amount of waste I have, right? So, I could start to serially sort of move these things, trying to, again, minimize the amount of waste I have, etc. Now, that's step 2, right? So I'm going to go ahead and keep these, and I'm just going to move them off now, because the next set of stuff that I generate is going to be generated again in this positive X, positive Y quadrant. Okay. Let's take a look at what that involves. Step 2, we just finished. Step 3, use your Grasshopper GH file from this weekend to populate your new grid shell, right, surface, with your shading component system. Some of you are primed right now to do that. A few of you are still working out some of the kinks. That's fine. Right? You'll see that over the next 2 weeks or so, the key thing is to probably on Wednesday, be prepared then or by the end of the week to sign up for laser cutting time. Then you have an appointment. Then it's a matter of reverse engineering from that appointment, right, to make sure that you hit your deadlines. Okay? And some of you might be starting from a little further back, and some of you might be starting a little closer to the end. So that happens, right? And keep in mind that this is prototype number 1. It's a first draft, right? So I'm not expecting perfection. In fact, some of you will fail miserably. As long as you bring in the pieces and show me how you failed, you'll get full credit. And we can have, I think, a really fruitful discussion on why things went wrong and how to fix them, right? That's how we learn. How many of you have had to build a model and you get to the end and you're like, this sucks, or I did this completely wrong, or this is at the wrong scale, and you have to redo it, right? Yeah. And in fact, this sort of process of iteration, this sort of cyclical process where we do things, look at them, revise, do them again, right? I mean, we recognize that as being a critical quality of the design process, the creative process, right? So anyway, so let's go ahead and do that. And then step 4, which we'll also move into with the time we have left, modify that so that we can unroll things and then add labels. Oh yeah, so good, right? Okay. What I'm about to show you, to start off with, this file is an example file, and it's posted in case you need to refer back to it. And it's easier to look at that in situ rather than sort of go back and forth and listen to my voice over video, okay? But needless to say, when it comes to unrolling things in Grasshopper, there's no native unroll in Grasshopper. We have to download a third-party plugin that's free. It should work in both the Windows and Mac side, operating system. It's from a company called Proving Ground. They do a lot of consulting with, besides doing plugins and extensions, they work with firms that can't afford to have their own unit to devise these tools for them, so they'll be consultants on things and help, figure out the skin of this envelope for, Qatar's next FIFA World Cup stadium or whatever it is, right? Okay. Anybody been to Doha? It's pretty magnificent, actually. Both their airport and their soccer stadium. All right, so anyway. Let's talk about that, right? So, again, I have my default layer. I have these all other defaults, layer 2, layer 3, layer 4, layer 5. I have what used to be layer 1. I've named it shell geometry. That's where my surface is, right? And then I also have V-strips, U-strips, cut and score, which are all the things, all the layers that Rhino script generated for me. And then put all the different right pieces of geometry in the right layers for me, okay? So you can see that I have on the underneath of this surface my structure, right? 10 by 10 grid of cells. And now it's time to do the same thing that we've been doing, but now with this surface, we'll open up our parametric shading component, and then we'll plug this surface in on the very left until it's divided 10 by 10, since I did that 10 by 10 with the Rhino script. And then everything will line up. It'll be so fantastic. And then we'll talk about how to bring those shading components, flatten them out, okay? All right. So when last we talked, I think I had, here's one of the example files I had. Let's just open it up. This one right here from this morning. All right. So you can see that this thing, not unlike what you guys were up to, right? Takes a surface, the very left, divides it 10 by 10, creates a set of like checkers, quads, right? Divides it up to that chessboard, columns and rows. Right? Then I break it up into its faces, constituent edges, and vertices, and I start to connect the dots with surfaces and create a three-sided pyramid. Really boring, honestly. You guys have better stuff. Okay? In order to do that, I take some of these faces, I place a point there so I can get both location for an apex for the top of the pyramid, but also that sort of normal direction, so that as the surface curves, the normal direction sort of changes with it, cell to cell, right? And so let's just take a look and see what that does. Let's set one surface, and now I can give it this red surface that I made, right? Ah, look at that. And now let me just select the right things here, there, here, and here. There we are. Yeah, right? Now it's populated. Let me turn off that red surface in Rhino. Let's look at it, right? Like, yeah, those things line up with the grid, exactly. Like the ribs and everything from the, right? There's the same Rhino methods of dividing the surface in the Rhino script as it is in Grasshopper, right? We're just using the same, what's it called? Well, it's the same geometry, let's just say that, right? And so, yeah, everything sort of just works. It's kind of nice, actually, for once. Yikes. All right, so now what else is it doing? Let's see here. It is adding a label to each cell so that I know that 0, 0 is this way on this corner, and 0, 1, 0, 2, all the way to 0, 9, 10 to 19, 20, 29, right? And it's taking each of these shading components and unrolling them out here and labeling them as well with the exact same 1 to 1, 0 to 0, 0, 0, 0, 1, 0, 1, all the way to 99, 99. Now, you'll see that this text widget's a little funky, right? It's going to give you just like text. It doesn't really like have any curves or anything to it. So I'll show you when we bake that in that you can change all of those all at once if you bake them all in their own, shake it up and down, sorry. Bake them all in their own layer. Then you can select them all at once and change all of their properties, like the font size and the font and everything else, okay? So there's some mostly all works, just works, but there's still a few little trivial details that you have to manage here, okay? But the hard parts, all the really time-consuming stuff, largely automated, right? So let's take a look at what's happening here in Grasshopper first, and then I'll show you what happens when we bake this into Rhino, okay? So all the stuff that's not in the shaded violet areas, you've seen this before, right? To take a surface, we call it a two-dimensional domain. We divide each of those two-dimensional domains into two-dimensional domains, 10 times by 10 times. We plug those into thing with the ISO trim widget in order to get a series of batches across, right? To generate the actual subsurfaces. And we explode them, get their faces, edges, and vertices, and then we're playing games with the data trees and the lists, connecting dots with surfaces, etc. Right? So you've been here before, right? The new stuff is here in this violet box, and here in this violet box. What does this violet box do? I made a little notation for you guys. This is all about making labels. Right? And then up here, this is all about joining those components together. So if you have any surfaces with common edges, they'll be joined together as a polysurface. Right? That's what that join does. And then we use the unroll, and we say don't explode, and it lays them all out flat. And then we move them into a grid even. Now we can adjust the spacing of so that instead of stacking them all up, overlapping, it'll space them out, and we can just sort of move those sliders for the spacing, tighten them up just right so that we can, again, try to minimize the amount of waste materials. You can see that we're tagging things on the cell level in the three-dimensional model, and we're also making the exact same tags and deploying them on the grid with the flat tags. So that we can start to see. If I have this and I pick it up and it says 0, 0 on it, I've inscribed in the laser cutter, I can go back to the Rhino model, the grasshopper model, look at it and go, oh yeah, this is 0, 0. And then this one, as a result, goes here. All right. Now, this unroll component isn't found anywhere in any of the standard tabs. You'll see now I have two tabs called Lunchbox and Lunchbox Machine Learning. And that's because I installed the Lunchbox plugin or whatever. And as a result, now under this tab, Lunchbox tab, if I go to Utilities, I have something called Unroll BRAP, Unroll Polysurface. Okay, that gives me that tool right there. Now, how to load that? I'm going to go ahead and just close Grasshopper for a moment and show you the steps to this. It's not hard at all. And in fact, I included the link here in case you want to look at the other things that they develop. But their instructions are just as good as mine. All you have to do is in Rhino, type in package for package manager and load up the package manager. What this does is when you have third-party plugins that Rhino then vets and says these are safe, they'll actually package them up into something you can search for them through Rhino interface. Instead of downloading an executable and your laptop goes, you downloaded this from the web, are you sure you want to run this? Okay, so all you have to do then is search Lunchbox tools. And then you just say install and hit OK. And it installs it. You close Rhino, and when you open Rhino back up, it'll open up everything up, and it'll also, if you're looking at the progress bar, it'll say it's also loading Lunchbox tools plugin. I've already loaded it, so I'm just going to hit cancel. But then when you open up Grasshopper, you have these tabs, Lunchbox. And that gives you the Unroll widget. Okay? So, let me just select all of these things. And solution, let's just, let's turn these off. Let's disable them. All right. And I'm just going to start from generating my pyramids. And let's just look and see what I have, right? So you can see in my case, I just have a three-sided pyramid. It looks like a cheese grater that I got bent up in the dishwasher or something. It's creepy looking, but whatever. Maybe I like spikes and into armadillos or something, I don't know. But what you can see is that I have three triangular surfaces, right? In fact, not a big surprise, right? One surface, two surface, three surfaces, right? Now they're individual surfaces. So one of the things I'm going to do is I'm going to say, well, you know, look at this. I could do 3 triangles and then triple the amount of joints I have to glue. and triple the amount of effort I have to put in trying to get everything to sort of line up nicely and look good. Or I could say, really, this is one shape, right? Like it's basically it's basically like a a shape that where I can score the folds and then fold it into what looks like three triangles, right? Yeah, I think that hopefully that's intuitive. Right? So what I'm going to do is I'm going to join them into a polysurface. So if I go to Surface Tools and I go to Utilities, I have something called BREP join. Again, BREP is just a boundary representation, just a fancy name for, if you think of a Venn diagram, the larger sort of polysurface, and inside of that the circle of all surfaces. Right? So BREP is just a abstract concept, but it's the label that we give for surfaces and polysurfaces in particular. Okay. So BREP join, and I can plug these in. Now what's interesting about this, since these are all in different tree data branches, right? So we see that we have the dashed lines, and so we have, again, 99 branches going from 0 to 100 branches going from 0 to 99, and then one triangle in each one, right? So what it's going to do when I plug in this one and the next one and the next one, it's going to try to join this one with the first one in the second set, and the first one in the third set. And they should share edges, so that should work really well. If you don't believe me, I just did that. I just held the Shift key, plugged each of these in, and yeah, I still have one polysurface in each of those, right? But they're, again, now three of those triangles combined, joined into a polysurface. What that allows me to do is then pass these to, as the argument, the ingredient into the unroll command, right? So now each of these cells, each of those shading components is one sort of joined polysurface, right? Which is nice. I'm going to go ahead and plug them in. Here are the BREPs. I'll plug them into this. It's asking for a BREP to unroll. And now down here it says join. Do you want to keep them joined together if there are any polysurfaces? Do you want to keep them sort of stitched up, or do you want to explode them out? So I'm going to go say, do I want them to remain joined? I'm going to go ahead and toggle that to true. Really important. And now it's going to take all 100 of these, and it's going to unroll them and pile them up at the 0, 0, 0 point. So it's not very useful to see 100 of them all overlap like this, like a big sandwich, right? That's why the next step, I make a grid, and then I move these along the grid, right? And then I can change that grid so I lay them all out flat, but they're not all, none of them are overlapping. That's really important in this grid. No one any overlaps, right? Okay. Now, we've been here before, right? We've made a grid of points, right? Oh yeah, that was like week 1, right? We made a list of numbers that climb from 0 to whatever, and then we plugged them in as X and Y values and we get grid points, right? We use the cross-reference. All right, let's do it the easier way. There's a widget that does it for us. We go to the Vector tab. We can make different types of grids here. Similar parameters, but fewer widgets, right? So we can make a rectangular or a square. Let's do a rectangular. That assumes that we can give different spacing in this direction versus this direction, right? And so doing, maybe tighten things up and, again, try to minimize the weird offcuts that we get and the amount of material that we end up throwing away or recycling. All right, so let's do rectangular grid. Now, it's going to ask us several things. First, the point to start with, and I'll just use the world X, Y. That's fine, I don't care, right? But then it's going to say the size of the grid cells, right? So that's going to be a variable, like I said, a number slider. And then it also says the number of grid cells in the X and the Y, right? Yeah, that's very important. So what we're going to do is we're going to go all the way back here and say, well, what governs the number of grid cells we need are these sliders right back here. If I change those, the number of cells I have on that surface are going to change, and therefore the number of components I'm going to have change, and therefore the number of points in my grid to lay out those components are going to change, right? So now if you think about this, we have 10 by 10, so we have 100. Right? It's asking us how many grid cells are we going to create, right? So if we just plug in the 10 by 10 here, let's take a look and see what it does to us. We'll try it. Here we go. Come on now. There we go. There's the points. And now we'll generate these. Let's see. We'll make a slider that goes from 0 to 10 or something probably way too large, but we'll do it anyway. Make a copy of that, plug it in for the Y spacing. And we'll take a look at this grid. Right. Now, what we're going to need are the points, right? Because we're going to move everything away. We're going to do a translate command. We're going to say, let's take the first one. Let's move it from the 0, 0, 0 point to the first point in the grid. And then the second one, the 0, 0, 0 point to the second point in the grid. We'll just do a series of translations or moves, right, based off of those points. And when we do 10 cells, we get 11 points, right? So what we need to do, really, is take whatever those sliders at the very beginning are and subtract 1 from each. And then plug that in for the number of cells so that we get the right number of points, right? Yeah. All right. So does that make sense? So if I do 10 cells, I get 11 points to define those 10 cells, right? I have 11 lines, grid lines, in either direction. And so I want the points. That's what's really handy to me. So I need 10 by 10 points. You can see right now with 10 cells, we get 11 by 11 points. 121 is the square of 11, right? Okay. All right, so we can do this several ways, right? We have math. We can just do subtract and say plug this value in and subtract 1 from it. But let's just do it maybe a quicker way. We'll right-click on where we're plugging these in to the input. And down here, this is where we typically find things like flatten. If we have a data tree, we need to flatten into a list. Or we reparameterize a curve if we want it to go from 0 to 1, right? Okay. But there's something called expression. And so what I can do is I can refer to what we're plugging in as x, and I could say -1. And so what it'll take is it'll look at what I'm inputting, subtract 1 from it, and use that value instead. Okay? So I'm just writing a quick custom expression for both of these inputs. X -1, and commit to changes. Now, da-da, I got 100 points, 10 by 10. I know the square of 10 is 100. Damn it. And so we're right on track now. All right. Last but not least, let's move these things around. All right. So what I'm going to do is I'm going to say transform and move. All right. What am I going to move? Each of these. What am I going to move? Or where am I going to move them? I need to give it a list of 100 sort of translation vectors, right? From here to there, from here to there, from here to there, from here to there, right? So take the first one and move it a little bit, and the second one, move it more, and the third one, move it more. All right. So it wants a translation vector, right? And so what we'll do, that's easy enough. We'll go to vectors, and let's make a vector between 2 points, and we'll use this point, this plane, wherever that's located, and then we'll feed it also these points, and then we'll get a series of translation vectors. I can tell you guys are so excited. And maybe, we'll just leave it as is. Maybe I'll flatten these, because what I'll be doing is giving it a list, and so I want to give it a list up here, right? We can see that it's dashed. We have a data tree. I usually don't want to match lists with data trees. I want to match lists with lists, or data trees with data trees. So I'm going to go ahead and flatten that data tree, because I'm going to be plugging in a list. So here we go. Here's those. And let's see what we got here. I'll go ahead and flatten these as well. Yeah, okay. Maybe. Yeah, there we go. And let's actually pick the point that we want now, right? I mean, doesn't that sound good? Right? Okay. So I'm just going to go to vector, and I'm going to say, let's make an XY plane. And where do we want to make that XY plane? Well, we'll get to there. By default, I think it's going to be at 0, 0, 0. But if I right-click on this and say set 1 point, I can set it anywhere, right? I can click on my screen and set it anywhere. And so now this translation vectors, now we have these things set up in the grid. Let's go ahead and take these old version and turn off the preview, and now we can adjust this grid until we have no overlaps. Okay? So that's all I'm doing with the stuff in the Bible. That's all I got. right? Or I could just, and let's just turn all this stuff back on. I don't know what the sound effect for that would be. And trust me, I'm not going to do it in front of you guys. There we go. All right. Now notice this grid of points we made, I'm also using it down here to show where I want all the labels, right? Yeah, all right. So how am I doing the labels? Let's take a look real quick. Again, I come back to the very far left. How many labels do I need? Well, according to my number sliders here, 10 by 10, but I can always change them. So I'm going to link up the number that I need to the number sliders in case I would adjust that, right? So if I adjust the number sliders, nothing will break. Everything will adjust with it from left to right. Okay. So what am I doing in the series? You guys tell me this. Someone. What's the series do? Series widget? What does it create? A list of numbers, yeah, that are ordered in a certain way, right? The start point, right? Start number, the increment number, and the amounts of increments, right? So we start with 0. We say we need 100 of these, and then there's it's an increment of 1 each time, right? So we go 0 to 99. Let's test my thesis here. Yeah, 0 to 9. There we go. What did I say, 99? 0 to 9, yes, because we need 10 each, right? 0 to 9. And then I just cross-reference those, right? So then I get a bunch of numbers that I can plug in and join together. Now this is called a text join, right? So what I'm doing is I'm generating a set of numbers, 0, 0, all the way to 99, and everything in between. 0, 0, 0, 1, 0, 0, 2, 0, 2, 0, 3, 0, 4, all the way to 99. And then, so basically, I'm doing 0, 0, 0, 0, 0, 0, 0, 9 zeros, 9 ones, 9 twos, 9 threes, and then this one I go 0 to 9, 9 times, 10 times, 0, 9, 0, 9, 0, 9. I link those up and I get 0, 0, 0, 1, 0, 2, 0, 3, all the way to 99 by using the text join tool. I know it's a little weird, but that's how I do it. Yeah. And then I simply plug that in for the text and then this text tag widget asks where I want the text and then what text to display, right? And then there's something else, optional color. All right, whatever. Okay, so that's where I'm generating the text over here, right? Showing each cell. And then I also am doing it over here, showing the corresponding component, right? That sits in that cell. All right. Now, let's talk about the sort of weird idiosyncrasies when I bake this into Rhino and some of the things I can do with the text. Okay. We're almost there. 3 more minutes, I promise. Right? And we'll get through this all, and it'll be packaged up in Canvas so you can refer to it. Okay. So thanks for your patience. It's a lot, but you'll have to unpack this over steps over the next 2 weeks anyway, so it makes sense to put it in one place for you, okay, with the explanations. All right, so let's see. Here's tags, and let me just show you what this looks like. You know what? There's only 2 minutes left. I'll stop there, and I'll take the last 5-10 minutes on Wednesday and complete this, right? But starting off, we'll have Kyle in here talking about laser cutting, talking about the protocols, where to get the templates. How many of you have laser cut before? Here? Yeah? Okay, good. So some of you are familiar with the process. For those who aren't, don't worry. It's assumed that you aren't, so Kyle will help you out. And we'll go from there. Thanks again for your patience. We'll pick this up again on Wednesday. I'll post the Rhino script ASAP. And yeah, okay?